this week is very much just easing into the year, not really starting on grade 8 stuff just yet. As of next week, we will start with grade 8 content, and our first section is looking at numbers, like whole numbers, how we work with them, and so on, just that you know what's coming up. But sort of today, well, the rest of today's lesson, and then Wednesday, we're going to just recap some important stuff that you need to know from grade 7. Now, I think what is important to note here is that those of you that maybe weren't feeling so comfortable with maths at the end of grade 7, this is now the time where you can ask questions. We're also going to take like the first couple sections quite slowly, go in detail, do lots of practice. So if you weren't feeling comfortable at the end of grade 7, don't stress. This is now the chance to hopefully catch it up and feel more comfortable with this stuff. Alrighty, so what I have here is basically, I mean, I say a grade 7 exam. It's just some basic questions that you would generally see in a grade 7 exam. Now, we're going to do most of these questions. I think I've just lost my marbles a little bit. We're going to do most of these questions, if not all of them. But what I am going to start with is the questions that are quite important in terms of just grade 8 maths. And then we'll come back to the other ones as we go along. So this is now the point where having your paper ready, your pens ready, sitting at a desk, studying somewhere you can write is really important. We're going to go through these questions as we go along. I might ask for answers, which you can put in the chat, or you can raise your hand, or we'll chat about certain things. But yeah, this is now where we're at. So we're going to start with question 2, just because, again, I want to start with the sort of important stuff for grade 8, and then we'll move on from there. We are going to just sort of go along, chat about these things. If you have questions at any point, just remember, raise your hand or put it in the chat. So our very first question here is asking us which value is bigger, a half or 2/3. Now, I suppose the first question is, what sort of numbers are these? And you can just quickly put it in the chat. Are they decimals? Are they whole numbers? Are they fractions? Are they percentages? What sort of values or what sort of numbers is a half and 2/3? Well done, Nara. Very nice. Okay, so these are fractions. And so that's important to know because fractions give us different information to what a whole number would give us. Now, you're going to have to excuse my drawing because I'm a little bit out of practice, so it'll get better as we go along. You'll see I fight with technology quite a lot, but it's fine. Yeah, okay. So as we sort of go along here, fractions represent portions of a whole. Now, we know that we can sometimes have a whole and then some, but essentially that's what fractions do for us. So if we think about a half is, she's just going to fight with me today, which is fine. We're just going to accept it. A half would be represented by that sort of beautifully colored in segment over there, whereas 2/3 would be splitting this pie or the circle that I've very artistically drawn here into 3s. Okay. And then if we're talking about 2/3, we're talking about 2 of those segments. So even just visually looking at this and seeing which one represents the bigger portion, hopefully we can see that just through an image. Does anyone know, or can anyone give me another suggestion of how I could go and work out which fraction is bigger by not drawing a picture? So how else could I go and see, is a half bigger or is 2/3 bigger? Have a think. And don't stress, I know that we're all, some of us still on holiday, our brains are still getting back into it. Okay, so let me ask you a second question. Which one do you think is bigger? Do you think a half is bigger? Do you think a half represents more? Or do we think 2/3 represents more? Okay, we've got a bit of a mixed batch here. Some saying half, some saying 2/3. Okay, so let's think about how we can do this. So we've got our beautiful picture over here. I tried my best. Let's see how we can maybe do this numerically or with numbers. Now, if we think about these two fractions that I have here, the first thing that's very important to notice is that the denominators or the numbers at the bottom are different, okay? So hopefully we all remember when we talk about fractions, we've got two parts to the fraction. Oh, golly, this thing's just gonna fight with me today. It's fine, guys. Everything will eventually come right. We've got two parts to the fraction. We've got the top, which is our numerator. I don't know if this is gonna work. No, okay. We've got the top, which is our numerator, and we've got the bottom, which is our denominator. Now, when comparing fractions, what is often very important for us to be able to do that is to have the denominators be the same. And this is where we talk about, come on, pen, why do you hate me? I thought I tested this all, guys. I'm very sorry. It'll come right. What we want is a common denominator. Come on. It's just going to fight with me. So we're just going to work through the technical issues that I'm clearly having here. Okay, a common denominator. We'll get there. So if we think about these two denominators, 2 and 3, we basically want to find the smallest number that both 2 and 3 can divide into. So think about like your 2 times tables and your 3 times tables. What is the smallest number that 2 and 3 can divide into? Another way you could phrase it is, what is the lowest common multiple between 2 and 3? And if you need, you can list out your times tables for yourself. I'm just gonna close this for a second.
Y'all are doing really good, my babe. So remember that if you're feeling somehow, you can also, if you know the answer or if you think you know the answer, you can raise your hand so that you can talk to Teacher Sam and I. Like this, we're making it interesting. And don't worry, we'll correct you if you're wrong, you know, and it's good. You learn by making mistakes, okay? So if you don't understand and you're sitting there, you're like, what's going on? Please do raise your hand and say, ma'am, I don't understand. Okay, so it's allowed in this class to say that you don't understand. Okay, if you get everything, also very good. You always have to comment on the chat and say, I'm getting this. I'm okay. You know, so that we know. Teacher Sam and I can know and can move on or do it slowly or a little bit faster. Like this, you don't get bored.
Okay, so you guys, I'm going to have to figure out this technology at some point, but clearly not tonight. Okay, so
yeah, the numbers.
So it worked perfectly fine when I did all of my prep. Now, do you think it wants to work for me? No. Why on earth would it want to? Okay. Sometimes me and technology are just not friends. Okay, let's try. Right, I'm going to use my finger because apparently this is going to work better. If we think about our times tables, see, look how much better that looks, and that's with my finger. Oh my gracious. If we think about our times tables, so if we think of our 2 times tables, we know that we've got 2, 4, 6, 8, and so it keeps going. If we then think about our 3 times tables, we've got 3, 6, 9, and so we keep going. So I asked you, what is the smallest number that both of these can divide into? Now, if you have a look at this list, the sort of first number that appears in both of these lists is 6. And I'm always put that on the chat there for us. Our smallest common multiple, or the smallest number that can divide into both, or that 2 and 3 both divide into, is 6. And so what we want to do here is we now want to go and say, okay, cool, now that I know what my lowest common denominator is, I want to see if I can make both of these denominators the same by working with that lowest common multiple. And so now the question is, well, both of these must now become 6s. So the question is, what do I times 2 by to make 2 6? Well, I know that if I times that by 3, it's not beautiful. I'm going to try. Let's see what happens. No, it's not going to work for me. if I times this by 3, I'm trying really hard not to get very angry with this thing. Times it by 3, I'm going to get 6. If I times 3 by 2, I'm also going to get 6. And now if we remember anything from fractions, we know that what we do to the bottom, we have to do to the top. So if I multiply my denominator by something, I also have to multiply my numerator by something. And so now if I look at the fraction of a half, I could also write this as 3 over 6. And if I look at the fraction of 2/3, I could also write this as 4 over 6. And now what we see is that these denominators are exactly the same. So it makes it much easier for me to compare this. Because if I now were to draw a picture of what this represents, it's not going to be pretty, guys. We're just going to roll with it. If I divide my pi into 6, a half is then represented by 3 of these portions. Whoopsie daisies. So there's a half. And then 2/3, now that we've got the denominators the same, is then represented by 4 of these segments colored in. And so now this makes answering the question of which one is bigger a little bit easier, because now we've got more comparable values to work with. So I'm going to ask you again, which one do we think is bigger? Do we think 2 over 3 is bigger, or do we think a half is bigger? Based on what we've just done, what do you think now? And I see Mbali's hand is up. Bali?
Ma'am, can I answer the question, then say what I wanted to say first?
Definitely.
So ma'am, 2 over 3 is the bigger one because the denominator doesn't change.
Okay, what do you mean the denominator doesn't change?
It stays the same.
So when you say it stays the same, what do you mean? Because we went from 3 to 6. So how did it stay the same?
Ma'am, like grade 6, my teacher used to say, for example, I have the numbers that we have here now. So my teacher would you look for the number that you can multiply so that you can get the same denominator as the other bigger denominator.
Okay.
So that's why she used to tell us that the bigger denominator always stays the same.
Okay, I see. So sometimes that definitely is the case. In this case, both of the denominators had to change. But I do see what you're saying. Sometimes the biggest one will be the one that we work with.
Okay, ma'am.
Okay. Right, but as Mbali said here, the biggest value, or the bigger value, is then 2 over 3. And we can see that in our beautiful picture that we have going on here. All right, so when working with fractions, what is important to understand is that it's representing parts of a whole. And so sometimes what we need to be able to do is we need to be able to make the denominators the same in order to actually understand what they're saying and understand or be able to compare 2 sets of fractions. Okay, now, because, we had so much fun at the beginning.
Yeah, and I think Lara had something to say, and I just saw Lara's hand disappearing. Hey, Lara, do you still have something to say? Lara, if you have something to say, you can still raise your hand and we can listen to you.
Ma'am, it's okay.
Sure. Okay. Alrighty, guys. So
that's cool. Yeah.
Yeah, no problem. So what let's try to get it done. Let's see. We'll see how far we go. So what we're going to look at in this question is the list of numbers that I have given you. So there's 21, 36, 111, 3/4, 19, 12, and 4 over 3. And from this list of numbers, I've asked you to tell me which ones are specific values. So the first one is a prime number. Can anyone tell me what a prime number is? You can raise your hand or you can put it in the chat. What is a prime number? Lara?
And a prime number is something that can be divided by 1 in itself.
Okay, perfect, excellent. So guys, a prime number is a number that can only be divided by 1 and itself. If you think about the word factors, hopefully we've all heard of factors. If you haven't, don't stress, we're going to chat about them. Basically, the only factors a prime number has is 1 and itself. So as an example, let's see if this pen's going to work. No, it's not. As an example, when we talk about factors, if we think about the number, let's say 4. 4 can be found by multiplying 1 and 4. And it can also be found by multiplying 2 and 2. So 4 has more factors than just 1 and itself. If we then think about the number 3, the only way I can find 3 when I multiply is to say 1 times 3. And so 3 would be an example of a prime number because it only is divisible by 1 and itself. So if we look at these numbers in this list here, take a second, go through all of them carefully. Which number is a prime number? Put it in the chat, raise your hand, I don't really mind. Which of those are or is a prime number? Oh, Callan and Riley, I was about to pick on you. If you want to raise your hand again, feel free. Okay, seeing some awesome answers coming through here. Very nice. So from our list here, 19 is definitely a prime number. I can only get 19 by multiplying 1 and 19. A couple have said 21. Now 21 is a bit of a tricky one because if we think about 21, the factors of 21 that I can get, is I can get 21 by multiplying 1 and 21, but I can also get 21 by multiplying 3 and 7. So because it's got more factors than just 1 in itself, it's not a prime number. The other prime number that we have here is 111. Okay, 111 can only be found by saying 1 times 111. And so we've got 2 prime numbers here from this list of numbers. But very nice, I saw lots of 19s come through, which is awesome. And don't stress if you didn't get 19, we'll get there. And like I say, we're still going to talk a little bit more about prime numbers. So hopefully after that, that'll make sense. Alrighty, guys, I know that we didn't do a lot of maths today, but like I say, we've got Wednesday's lesson still to go through some of this revision stuff. And I think it was important that we all just sort of got comfortable with this lesson and this class. So I'm going to end off there. We're going to carry on with this on Wednesday, so do not stress. We're going to do a lot more maths on Wednesday. But we will see you then. Oh, am I lying to you? 311. Lied. 19, guys. Thank you for everyone being so on it.